Dear friends, welcome to yet another installment of Orbital Geek. In this video, we'll explore the intriguing simulation theory and 10 chilling clues that suggest our reality might be nothing more than a sophisticated computer program. From philosophical arguments about the high probability that we're in a simulation, to anomalies in the cosmic microwave background and quantum paradoxes, we'll unravel disturbing evidence that our universe could be a vast cosmic game. But what if we proved that we really are bits of data? Would the simulation controllers press the off button? Watch until the end to discover this controversial question and how it could impact our lives forever. Don't miss it. Have you ever felt as if reality was out of place, as if something wasn't right in the world around us? Well, prepare to question everything you thought you knew. In this video, we'll dive deep into the simulation theory and unravel 10 chilling clues that suggest our existence might be nothing more than lines of code in a hyper-realistic computer program. Your comment is invaluable to us. Help the algorithm recommend our videos to more people, which is crucial for the growth of our channel, especially at the beginning of this journey. If you can, leave a comment, even if it's just a simple hello. Your participation makes all the difference. Starting off, we're talking about the high probability argument. Some philosophers, like Nick Bostrom, have formulated a theory that seems unreal, but is actually taken quite seriously by some scientists. They say there's a high probability that we're living in a simulation. Bostrom argues that one of these three situations is probably true. First, that extinction is the norm. Almost all civilizations out there, like ours, never get past a certain point. They self-destruct or are destroyed before they can really obtain advanced technology. It's a bit scary, isn't it? Imagine countless civilizations reaching the peak of greatness, only to fall into the abyss of extinction. It's like a cosmic Russian roulette. The second scenario suggests that no advanced civilization engages in simulation games. Civilizations that really reach a high level of development may decide that recreating simulations of their past, like a super-advanced version of a genealogy site, is tedious or pointless. Therefore, they don't bother creating these vast virtual worlds to observe their ancestors. The third scenario proposes that all of this is fiction. This is, without a doubt, the most disturbing of the scenarios, in which we are really living inside a gigantic computer game. Our entire universe, with its stars, planets, and our breakfasts, is nothing more than super-advanced alien software running on a cosmic computer. But why is this disturbing? Well, if we were in a simulation, who's in control? What happens if they decide to shut everything down? It's like being a character in someone else's video game. This leads us to question: are our choices really ours, or are we just following the code written by some cosmic programmer? This theory gives new meaning to the question, what is reality? And honestly, it's a bit scary when you really think about it. Next, we'll talk about the second law of infodynamics. A physicist studying mutations of the SARS-CoV-2 virus caused quite a stir with allegations suggesting we might be living in a simulated universe. Dr. Vin Vopson, the scientist behind these claims, introduced the second law of infodynamics, suggesting that mutations in the virus are not random, but follow this new law. He discovered that information entropy, a measure of disorder from an information perspective, decreases over time in these mutations, which contradicts the typical behavior of entropy, which tends to increase. This discovery goes beyond a simple peculiar observation. Vopson argues that this could revolutionize our understanding of evolution and even suggest a more ordered and deterministic universe than we imagined. He connects this idea to the possibility that the universe is a huge simulation designed to optimize data and minimize computational needs. In his studies, especially with the constantly mutating SARS-CoV-2, Vopson observed patterns that, according to him, cannot be simply dismissed as random. He suggests that if we start viewing genetic mutations deterministically, we could predict mutations before they occur, which would revolutionize genetic therapies and vaccine development. However, the scientific community remains skeptical, and more research is needed to prove these bold ideas. Vopson's theory, although intriguing, remains on the fringe, and proving it may involve experiments that verify whether information itself has mass, a concept that could be linked to everything from the thermal death of the universe to why symmetry is so common in nature. Therefore, Although the second law of infodynamics opens up fascinating possibilities, there's a long way from hypothesis to accepted science, especially with such big claims. But who knows? Sometimes the strangest ideas lead to the most profound discoveries. Now, let's talk about limitations in the laws of physics. Think about the speed of light. Nothing can go faster, right? It's as if the universe had a maximum speed limit, and no matter what you do, you can't exceed it. This reminds some people of a video game, where the game can only process things up to a certain speed, so it sets limits to keep everything running smoothly. Then there's Heisenberg's uncertainty principle, a strange rule in quantum mechanics that says you can't know both the position and velocity of a tiny particle at the same time. It's as if the universe economized processing power, not deciding where something is until it's absolutely necessary. A bit like a game that only loads the parts of the world you're looking at to save memory. These rules of physics might make you wonder if they're just programming constraints in a gigantic cosmic simulation set up to keep things manageable for whoever is running the show. Isn't it a bit like we're living in an ingeniously crafted game where certain things are forbidden to prevent the whole system from crashing? It's definitely a wild thought, but it certainly makes you look at those science classes a little differently. Next, let's talk about the observer effect. Have you heard about the totally strange behavior of particles in the quantum world? In quantum mechanics, things get really peculiar because particles like electrons don't settle on a specific location or trajectory until we actually observe them. It's as if everything were potential, with no decision made until observed. This weirdness is known as quantum indeterminacy and the observer effect. Now, think about how video games work. It's the simplest analogy, so there will be a lot of talk about video games. They don't bother rendering every part of the game world at once. Instead, they show only what's in your current view to save processing power. It's as if the game said, "Why worry about the rest if you're not even looking there?" This is eerily similar to what happens at the quantum level. It's as if our universe were running a super efficient simulation, making calculations only when necessary to not waste resources. This parallel makes some people wonder if, maybe, just maybe, we're living in some kind of cosmic video game, where things aren't fully decided until they need to be. Next, let's talk about mathematical consistencies. Have you noticed how everything in the universe seems to follow a specific set of rules, almost as if everything were part of a gigantic mathematical equation? It's pretty impressive when you really think about it. From the way planets orbit the sun to how your coffee spreads when you spill it, there's mathematics everywhere. This isn't just a coincidence. The universe is actually incredibly consistent and can be described very well using mathematical principles, just like a computer program. This consistency makes some people think that maybe our universe is a bit like a game or a simulation. Imagine, in video games, everything from graphics to physics is governed by code, by mathematics. When scientists discover that even the most chaotic and complex systems in our universe can be defined by equations, it makes us question if there's some kind of computational basis behind everything. Why is this exciting? Well, it suggests that maybe our entire universe could be running on a vast cosmic computer, with every star, planet, and galaxy following a set of mathematical instructions. It's as if the universe were a big puzzle, and mathematics were the key to unraveling it. I know this might seem like a nightmare for many, like, oh no, not mathematics, the one thing I can't understand. But I really like mathematics. Well, I think we should all like it. Next, let's talk about anomalies in the cosmic microwave background. Here, we're looking at the oldest light in the universe, the cosmic microwave background, also known as CMB. This is like the universe's baby picture, taken shortly after the Big Bang. This light should be pretty uniform, but scientists have noticed some strange patterns and anomalies in it. It's as if the universe had a small flaw or some kind of cosmic watermark appearing in that ancient glow. Some people think these strange patterns might be like the digital artifacts you see in images that have been heavily compressed, or when your video game starts showing strange lines due to a graphical error. The most intriguing thing is that these anomalies might suggest a digital grid, or some kind of underlying structure to space-time, something similar to how pixels build your screen. If our universe were a simulation, you'd expect to see some clues on the largest scales, and these strange patterns in the CMB are like potential Easter eggs left by the universe's programmers. Let's explore, with a touch of reflection and wonder, Gödel's fascinating incompleteness theorems. These theorems are like the supreme enigmas in the vast realm of mathematics. They reveal that, in a sufficiently robust mathematical system, capable of describing, for example, the entire universe, there will always be some problems that cannot be solved, regardless of the effort invested. It's as if we had an infinite list of riddles, with some simply having no solution. Now, imagine a computer simulation. Even the most powerful video game or simulation has its limits. There are certain things it simply cannot compute or display. Gödel's theorems suggest something similar about our universe. There may be cosmic rules comparable to a computer's programming constraints. These undeterminable truths might indicate that we live in an immense cosmic simulation where certain things are configured in a way that allows the system to continue functioning without crashing. It's a mind-spinning idea, as it suggests that some of the universe's mysteries are unsolvable because they're built into the code of our reality. Let's then address the bootstrap paradox, a concept in physics that's like a cosmic "which came first, the chicken or the egg?" riddle, capable of twisting our minds. Imagine you write a story where a scientist receives a mysterious notebook from the future, full of ideas that they then publish. Where did the original idea come from? Similarly, in physics, we have laws that could potentially explain how entire universes, including ours, could be created. It's as if the universe contained the recipe to create more universes, even itself. This kind of self-creative loop that spins our mind is like a video game where characters discover they can design and generate new levels or even new games within the game they're in. It suggests that our universe might be just one level in an epic cosmic game, constantly generating new universes in an endless cycle. So, the next time you ponder the mysteries of the cosmos, consider that maybe we're in a universe that's bootstrapping itself. Now, let's proceed to explore the black hole information paradox. Imagine throwing your favorite book into a black hole, a rather dramatic scenario, I know. According to the laws of quantum mechanics, the information contained in that book should be preserved in some way, because in the quantum world, information never truly disappears. However, black holes, those gigantic cosmic vacuum cleaners, seem to suck everything in and not allow anything to escape, not even light, giving the impression that information simply disappears from the universe. This dilemma is known to scientists as the black hole information paradox. And here things get really fascinating. Some of the brightest thinkers suggest that this paradox might be a clue that we're living in a cosmic hologram. They propose that all the information swallowed by the black hole might, in reality, be stored on its surface, similar to how your phone stores data in the cloud. And by the way, I'm still trying to fully understand what the cloud is. This idea is part of the holographic principle, which suggests that our entire three-dimensional universe might be a projection of a two-dimensional boundary. This concept, extremely challenging for the mind, aligns perfectly with the simulation hypothesis, suggesting that what we perceive as three-dimensional might be just another level of a vast cosmic simulation. And finally, in our discussion today, we address the question of manipulating the experiment. Imagine if we discovered, without a shadow of doubt, that our entire existence is just an immense computer game, and that everything we've discussed so far is in fact true. That's exactly what Professor Preston Green from Nanyang Technological University in Singapore is considering. He's quite concerned that if our scientists manage to prove we're living in a simulation, this could cause quite a stir. Imagine for a moment that Green's words are correct. As we begin to conduct experiments and discover that we are indeed a simulation, this could completely destabilize the purpose for which we're being simulated. Green suggests that if we become too curious and prove that we're mere bits of data in a cosmic computer, the beings who are running this show might simply press the off button. Why? Well, if we know we're in a simulation, we'll probably change our behavior to such an extent that the simulation will no longer be useful for the questions our creators are trying to answer about their own world. So, although it's fun and somewhat strange to think we're in a gigantic video game, Green warns that proving this could lead to game over for all of us. Therefore, proceed with caution. Understand? They have questions for us, and I also have questions for them. The simulation theory, although fascinating, faces serious scientific challenges. Many of the presented evidences, such as the uncertainty principle and limitations of physics, are inherent features of the nature of the observable universe, not necessarily signs of a simulation. Moreover, Vopson's alleged second law of infodynamics remains highly speculative and is not considered valid by most physicists. Still, seemingly absurd ideas sometimes lead to profound breakthroughs. Quantum cryptography and quantum computing, for example, were inspired by the strange phenomena of quantum mechanics. Therefore, the simulation theory cannot be completely dismissed based solely on current scientific knowledge. The real question is, are we prepared to deal with the existential consequences in case the simulation theory proves true? Leave your thought-provoking thoughts in the comments and join the debate. Don't forget to subscribe for more stimulating analysis of the mysteries of the universe.